Morning friends, today we are going to talk about the next part of the unit 1 of the paper 2 about the viscosity. There will be the liquid has the one more property or say resistance to the flow that known as the viscosity that may come for the MCQ. It is well known that all the liquid do not flow equally, that we should have this example. You can see the example of the water simply and the oil. They have the different flow. Those liquids like the glycerin, castor oil, etc. flow slowly are said to have the high viscosity, while those liquids like the water, alcohol, etc. flow readily, one said to have low viscosity. The rate of flow depends on the nature of the liquid and on the force which produces the flow. The liquid may be considered to be consisting of the number of molecular levels arranged one over the other. Write this. Then viscosity will be the defined as the force in Newton per square meter required to maintain the difference of velocity of 1 meter per second between two parallel layers of the liquid held at a distance of 1 meter from each other is called as the viscosity. There are number of methods of different kinds of measuring viscosity. The most commonly used is based on the Poiseuille's law, which connects the rate of flow of liquid through a capillary tube with the coefficient of the viscosity of the liquid and is expressed by the equation nu is equal to pi r raised to 4. This equation is there. You can see this equation. Very simple equation is there. R and P, pi r raised to 4. Okay, P is there. Then 8V. This equation we have to remember. Then the viscosity method is used to determine that Mark-Hawking equation is there. Mark-Hawking equation we will see one by one. Viscometry is a useful technique for the determination of the molar mass of the polymer. Then viscosity method is why the use for the determination of the molar mass of the polymer. The molar mass obtained by this method is the viscosity average molar mass, and the viscosity of the polymer solution is considerably higher than that of the pure solvent. Therefore, the viscosity nu0 is the viscosity of the pure solvent and the nu is the viscosity of the solution of the given polymer. Then the n by n0 is called as the relative viscosity, that is a eta r. Eta r is equal to eta upon eta 0. Then specific viscosity eta sp is the relative increase in the viscosity and is given by eta sp is equal to eta minus eta 0 divided by eta 0, which is equal to eta by eta 0 minus 1, that is eta r minus 1 is nothing but the specific viscosity. The ratio of specific viscosity, relative increase in specific viscosity per unit concentration of the polymer is known as the reduced viscosity. It comes for the MCQs, that's why I am highlighting this part. Okay, it depends upon the polymer weight of the polymer. Since reduced viscosity depends upon the concentration, it is necessary to extrapolate a plot of nu sp by c against t to the zero concentration. This extrapolated value is known as the intrinsic viscosity, that is a eta I. Eta reduced is equal to eta sp by c, and eta r is nothing but a limit c tends to 0 in sp by c, that is a where C is the concentration of the polymer in gram per decimeter liter. Then the intrinsic viscosity is determined experimentally as follows. You can determine that. Eta is equal to P pi r raised to 4 T divided by that 8 VL. Okay, T is equal to 8 eta VL divided by P pi r raised to 4. That equation you can use. Length L is there, T is the second, R is the radius is there. This is the Poiseuille's equation that earlier we have talked. Okay, here you can see. Then we can relate that with the time. T upon T0 is equal to eta upon eta 0, because in the this method, viscosity meter, we are going to compare with the time, and we are going to measure the time required to flow for this particular liquid. Okay, then the ratio of this particular, when we plotting NSP by C against the concentration, which is experimented 0, and this gives you the values of the intrinsic viscosity, and this intrinsic viscosity of the polymer is related to its molecular weight by the Mark-Hawking equation as eta I is equal to k m raised to alpha, where k and a are the constant. k and alpha, or say a, you can call it k m raised to a, or say alpha. These are the constant. Their values can be determined by measuring the intrinsic viscosities of the series of the solution of the polymer of the molecular weight, which have been obtained by the sedimentation method. The values of log eta I are then plotted against the log m, and according to the equation it will give you the straight line of a slope and a and intercept log k is obtained. You will get the log k intercept and the slope will give you the a value. Then the determination of the intrinsic viscosity, and here the determination of k and a of Mark-Hawking equation. This is the most convenient method to determine the molecular weight of the polymer. Since once the values of the k and a have been obtained for a given type of the polymer and a solvent, it is not only necessary to measure the viscosities of solution of known concentration in the same solvent. Here the equation is given, eta 1 by eta 2 is equal to d81 divided by dt d2 t2. Okay, you can compare this viscosity. Ostwald viscometer is used to generally measure the viscosities, and which can from which we can determine the molecular weight of the sample. Here that working is given. Here you can see two bulbs are there, bulb, okay, one and another one. Here you can see the capillary is there. Okay, Ostwald viscometer, there are the bulb in the wider limb of the tube is first filled with the liquid, and the liquid is then sucked up in the narrow or limb until the liquid level is above the mark A. The liquid is then allowed to drain. The time t for the liquid to flow through capillary tube x from, we have to that from mark to this lower mark, the time we have to note, and this time we will note. Okay, for the number of solutions we have to do, and from that particular we can calculate the viscosity of the unknown liquid. Then the refractive index, when the light passes from one medium to another, it suffers a refraction. That is a change of the direction. If a beam of light travels, that is shown here, from air or vacuum into the more dense medium, example is given liquid, it is refracted towards the normal, then I is called as the angle of incidence and R is called as the angle of refraction. The ratio of the sine of the angle of incidence and that of the refraction is constant and characteristic of that liquid. This ratio, constant ratio n, is called as the refractive index of the liquid. That is n is equal to sine I by sine R. That is the refractive index of a medium. May also be defined as the ratio of the velocity of light in vacuum to that in the medium. That you can remember, it may come for the MCQs. Here refractive index, here the detail is given about this particular thing. Specific refractivity is there, and molar refractivity is there. Then what is the specific refractivity? Specific refractivity is that it is independent on the temperature. The variation of the n with the change in the temperature is compensated by the variation in the density of the liquid. Molar refractivity is nothing but, in order to compare the refractive power of the different substances, the specific refractivities are multiplied by their respective molecular weight. The resulting product is called as the molar refractivity. Okay, molar refractivity is essentially additive property that is shown by the fact that the increase in the molar refractivity of the successive members of a homogeneous series is nearly constant. The molar refractivity is found to be constitutive property, as well as it is influenced by the arrangement of the atoms in the molecular factors such as the unsaturation, ring closure, etc. To eliminate the effect of the temperature, Laurent and Lorentz show the purely from theoretical consideration that R is given specific refractivity. Okay, this is about the refractive index. The definition is very much important. Then the molar refractivity and the specific refractivity, we have seen the definition. Here the explanatory part is there, that is not useful, that's why I'm not going in detail of this. Here we will stop. Thank you.